Hello, everybody. We started the webinar a little bit early to let you guys roll in and get a seat because we have so much content to cover today that we didn't want to spend the first couple of minutes of people like trying to figure out how their audio is working and stuff like that. So welcome to the February online meetup, where we will be discussing Kubernetes-native storage with Longhorn 1.1 and Rancher. I am joined today by my two esteemed colleagues, William Jimenez and Sheng Yang. Gentlemen, would you like to say hello and introduce yourselves?
Sure. Hi there, everyone. This is William Jimenez. I'm looking forward to speaking with you today about a new version of Longhorn.
Hi, this is Sheng, and I'm the team lead for the Longhorn team, and has been working on Longhorn for probably as long as you know the Rancher existed. So yeah, I'm very glad to be here and talk to you about the newest Longhorn release.
Awesome. Thank you both for joining us today. And before I hand off the meetup to the smart guys who are going to tell you everything about Longhorn, there's some basic things that we have to cover, just some little housekeeping rules. First of all, this is a meetup. It's not a webinar. If you've ever been to a Rancher meetup, you know that that's a pretty significant distinction. It means we're not going to be done on time. It means that we want you to ask lots of questions. In that little go to webinar panel thing over there, you'll see a thing called questions. Let me actually pop that out for me. So as you think of a question, just post it over there. I'll answer some of them. I'll flag some of them, and then we'll have Q&A throughout the course of the event. There are no bad questions, so just ask questions there. The only thing we ask is that you keep the questions related to the content that we're discussing today. If you have a question about something unrelated, another Rancher thing, RKE, K3S, but it doesn't directly relate to Longhorn, that would be better for the Rancher user Slack, which I'll show you in just a moment. We do live demos. All of this is live. And sometimes the gods of demonstration don't smile upon us and things go wrong, but that's fine. It just turns into a live debugging session, and that's also part of reality. We will endeavor to stay here until we get through all of the content, until we get through all of your questions, because that's how we roll. I mentioned the Rancher user Slack. That is the Rancher community. Oh, I didn't actually even introduce myself. I introduced the two smart guys who are in the meetup with me. My name is Adrian Goins. I'm the Director of Community and Evangelism, and the Rancher user Slack is my home. So that's where you can go to meet other people who use all of the Rancher products, projects, all of our open source stuff. Everything is in there. Ask your questions. It's a huge community. There's 23,000 people registered. There's some thousands of them online at any given point in time. That's the home. So I look forward to seeing you there. And with that, we can dive into today's content, which will be pretty basic. We're going to talk about Longhorn 1.1, and then we're going to show you Longhorn 1.1. And then if there are any questions that we didn't get answered throughout the demonstration, we'll address those at the end. So with that, I can hand it over. Who wants the slides? Sheng or William?
I think I can take these next.
Okay, I will make you a presenter.
Thank you. Yeah, it's always fun getting presentation technology to work. But the cool thing is, it's going to be far easier to think about and understand Longhorn than PowerPoint. So let's jump right in. So welcome everybody. And again, my name is William, and I'm the product manager for Longhorn, among some other technologies at Rancher or SUSE, I should say. And excited to show you what we've been working on with Longhorn in our latest release. And as part of that, though, I do want to recap about what Longhorn is. And if you're new to Longhorn, let's talk about how we came to be and how we got to this place today. So the first thing you should know is, why does persistent storage matter? Because this is the driver for everything we're doing with Longhorn. This is why we're so excited about the future of what Longhorn can offer. And what we found is Kubernetes, though stateless in the beginning, initially, Borg and Google's reference architecture was all about stateless apps initially. Kubernetes has evolved to where it is now a major component for stateful apps. Naturally, stateful workloads are gravitating towards the need for distributed orchestration. It just makes sense. And we were so comfortable now with Kubernetes that now we're ready to take on that next level of challenge of containerizing our persistent application. So just look at the survey on the right here. This is from the CNCF, the Cloud Native Computing Foundation, and I don't know where my mouse is, so I don't know if I can point to anything. And I think pointing at the screen, yeah, you probably can't tell that either. So look at the lower right.
That. This is a Mac PowerPoint problem. I have a fix for it.
Do you? That's
if you
awesome.
do Command-Shift-4 and then hit Escape, your mouse will return.
Oh my gosh, sounds like some black magic trick.
It's for some reason when you send Command-Shift-4, like you're going to do a screen capture, and then hit Escape, and your mouse is back. Boom. For some reason, when PowerPoint goes full screen, Mac OS thinks that it's like you're doing a screen capture, and it hides the mouse.
Wow. Wow. Okay. Amazing. This is why you need to. This is the value of technical expertise right here, right? Knowing these secrets like that. In this corner here, you can see this graph. And this is a survey from the CNCF back in November. And the really interesting thing is already in just a few years of Kubernetes being in production, half of the users, half the respondents are talking about running stateful applications. And for someone who's looked at these statistics for some time, I can tell you this is just a growing factor, a growing segment. You can already see sort of the indicative statistic here, which is not yet, but planning to in the next 12 months. If there was a not yet, but in the future column, I guarantee you would see there's another one that's even higher than this. But even just to say for the next 12 months, they have a concrete idea is pretty compelling that this number here is going to keep growing. So there's velocity here. And so what is Longhorn? Well, Longhorn is the answer to this problem of how do we then adapt to this storage first world, or how do we adapt to a world that needs storage? And we developed Longhorn to do just that for Kubernetes. Longhorn is a CNCF Sandbox project. So when we say we developed, as Sheng mentioned, he's been working on this project since its inception. It's been a Rancher Labs technology for some time, but we decided to donate it to the CNCF, and we're really proud of that, because what that allows Longhorn to do is become a clear technical choice for users rather than a vendor choice or any other external influences. And we believe that then it can really compete on its technical merit alone, and have the most interoperability and the most opportunity to help people with their storage needs. So some of the characteristics about Longhorn, what makes it different? Well, it's designed to be very reliable, very easy to use, and very low overhead and lightweight. It's one of the lowest overhead software-defined storage systems on the market. So this is very valuable for things like resource-constrained or embedded environments, or industrial computing environments that don't have the same hardware life cycles that a data center would. It also means that simply you're going to get more resources for the rest of your applications on a given infrastructure. How easy is it to deploy? Well, one click actually from Rancher, and in fact we'll demo that in a sec so you can see what I mean. That's distinct right there. I don't know of any other storage technology that you can install that intuitively, and that's sort of our calling card for Longhorn. That's just the indicate, that's the signal of what's to come with the rest of your Longhorn journey. When you see how easy it is to install, that's just par for the course, you'll see. And we try to make that consistent throughout the rest of the things you're going to do with Longhorn storage. We work with any certified Kubernetes cluster. So that means any CNCF certified Kubernetes cluster Longhorn fully supports. It's storage agnostic, or it's really file system agnostic for the most part. So we're a block level storage technology. So we're providing storage in a very generic block level format. And it's a Kubernetes first design. So one of the advantages of where we sat in the timeline of Kubernetes is we were developing sort of the back-end system right around the time that Kubernetes came on the scene. And so when we started getting to the orchestration and distributed systems design of Longhorn, we had the opportunity to leverage the Kubernetes architecture for this. So we actually built it on top of primitives and some of the functions in Kubernetes for our distributed systems design. So it's really cool just from a Kubernetes fan standpoint. If you're a fan of like controllers and watchers and the way the APIs are structured and CRDs and Kubernetes, if you're a fan of sort of this declarative and eventually consistent model of assigning infrastructure a task, then you'll find that Longhorn fits perfectly in with that. It's very understandable. And so the Longhorn story, because everything starts and ends with a story, as they say. Well, ours started like this in 2014 when Rancher was first forming as a company. We started on a storage technology. This was actually the first thing that we started on. It's kind of a lesser known fact is we didn't start with the orchestration problem because for a number of reasons. But what we found is that as we started developing storage, we found that actually orchestration was a bit of a more pertinent obstacle to our users and to our people trying to use storage. And so we decided to then switch focus a bit and focus more on the orchestration piece, which is how Rancher Cattle became a thing, and later Rancher Kubernetes and all the things that we're familiar with today. But we kept working on the R&D for Longhorn in the background. And then in 2019, we really started to ramp up the engineering investment as we saw, Kubernetes had now become mature and people now were starting to get ready for that next level of challenge, which is storage in Kubernetes. So it was the right time to sort of enter the market. And then we donated it to the CNCF in 2019, and then in 2020, which I admit seems like it didn't exist sometimes. 2020 is just this blur in some ways. But remarkably, that was also when we had our first general availability release and release some new features as well, such as air gap support and automated volume recovery and volume resizing, and really just that production level polish on the software. And so today we're excited to talk about Longhorn 1.1, which is our latest release, and it was just cut a few weeks ago, and it now adds a couple cool things. Actually, more than a couple, but here's the top things that we'll talk about today, which is ReadWriteMany support. And so this is implementing a means to consume block storage in multiple places, read-write simultaneously. And we're doing this through file system level abstraction on top. As any storage nerds in the audience would probably raise their hand and say, wait, you can't have two block schedulers write to the same block device. There'll be conflicts. There's no way to coordinate the two things trying to control that block storage, and that's true. And that's why we need a file system abstraction on top. And that's kind of some of the stuff under the hood that we're doing. But essentially, it makes it appear as if it's a ReadWriteMany file system that can then be just used across containers. We've also advanced our failure recovery mechanisms, and this is in the spirit of just trying to make Kubernetes and storage in Kubernetes more intuitive. And so we've automated a lot of the recovery pathways that would be executed when there is a volume failure. So that just makes the user experience richer. Another thing to note too is we also GA'd ARM support. So that's ARM64 runtime support for running Longhorn in non-Intel and non-x86. I shouldn't say Intel, excuse me, non-x86 because of course AMD platforms. ARM is just becoming increasingly interesting from both the embedded and edge standpoint, but also in the data center. We've got the Graviton 2 processor that Amazon has been developing and expanding their footprint on with their own silicon. Microsoft has hinted at their own silicon for Azure that they're going to develop with an ARM infrastructure, an ARM architecture. So even in the data center, ARM is exciting. So I think that's really cool that we were able to add that as well. And Rancher's recipe for production quality Kubernetes at scale. There's an inside hint here, or an inside nod to our what we call this graphic here. This is the Kube cake, as we call it, which is why there's a funny, recipe sounds very punny to mention. But this is how we bake our cake at Rancher and now SUSE. Is all these ingredients together creates a a delicious 3-tiered frosted cake that we refer to as the kube cake. And the idea is that you want all these things together to have a complete solution. Kubernetes, albeit the most powerful computing technology that we've seen in some time, without the frosting and the associated things that make it whole and complete, is not as useful to the enterprise. And that's what Rancher's mission and SUSE's mission is to bring that complete stack to our users, to complete the picture so that it's truly useful in their environment. And so with that, let's talk a little bit about Longhorn 1.1. And for this, I'm going to hand it over to the real smart person on the meetup today, Sheng Yang. And I'm going to stop my sharing. And so Sheng is, again, the architect for Longhorn. And so he will speak about some of the cool nuts and bolts of what's under the covers here.
All right, thanks, everyone. Thank you, Adrian and William. So as I mentioned, I have been working on this project for so long. So in fact, probably many of you already know me through our interactions on GitHub or Slack. So today I'm going to present to you what is new in Longhorn 1.1 and what is really the improvements we have done and why you should be excited about it. So before that, let's go back a little bit still for the newcomers for the Longhorn, and let's take a look at how Longhorn works. And in fact, it's very simple compared to other storage solutions like Ceph and others. So for example, if we have a Kubernetes pod requesting for one volume here, we are going to just create like 2 replicas on 2 different nodes. And then we're going to create an engine connect to those 2 replicas, and engine we are going to expose the volume inside the pod. So as you can see now, because we have 2 nodes here, so if one node goes down, say assuming the second node goes down, then the engine will still have able to connect to 1 replica and providing the volume to the pod. But if the node 1 goes down, so what will happen is, because this is the Kubernetes, so the pod 1 will be scheduled on the node 2 instead, and then the whole attaching and the recovery process will be kicked off automatically. So we don't have access on node 1, but we still have the access to the replica on node 2. So your data will still be saved. And this is what we call like how the Longhorn's highly available capability works. So as you can see, by using this model, we have designed to avoid a very big problem in the storage like software is how do you like make your controller, make your engine highly available. It's normally very hard. So when you have engine like share across different nodes and different volumes and have to handle like 10,000, like tens of thousands, hundreds of thousands IO ops or even million IO ops, and by itself, that's going to be a bottleneck. That's going to be very difficult to design to get this like elegantly and like also for the user to understand it. If something goes wrong, how can I fix that? So, but in the Longhorn case, as you can see, we have very separate concern on the data plane right now. The engine is always going to be co-located with the pod, with the workload. So if the workload that the node that workloads went down, then the workloads were going to be migrated. So the highly available HA capability of the engine of the controller is not going to be a problem for Longhorn. If you have like more volumes, we're going to create like more engine and replica processes and so on, right? So also you can see in this diagram, there's no interact with the different volumes data paths. They're always going to direct connect to the replicas and not so you don't see that say if one engine or one replica goes bad, the worst case scenario is only going to be affected the volume is actually serving. So that's why this is even more like reliable than the previous generation of the storage solutions, which you have because you have the replica and engine process shared by different volumes. So if something went wrong on that part, you are probably very likely you're going to at least lose the whole node, if not the whole cluster. So that is the one other thing like we designed in Longhorn to make it simple and more manageable than other traditional like storage solutions. But as you can see now, we have a bunch of like engine replicas, and those are so the previous storage software normally have them bundled together for a reason, and the reason is it's hard to schedule those individuals. But now we're in the area of the container, in the area of the Kubernetes, so that's no longer a problem for us. Kubernetes, we are going to be managing those orchestration for the engine replicas, and that enables the solution we have today, and that makes this possible. So for the Longhorn, I'm working on Longhorn project for a very long time, but why Longhorn and the Rancher as a different? So on the Longhorn side, well, Longhorn is a CNCF project. We definitely prioritize all our customers, not only just Rancher customers, but in the Rancher, there's in fact a little bit more of advantage of your using Rancher with Longhorn. So because first, Rancher has this amazing catalog app features, and you can one-click deploy Longhorn, and that is very easy for many users to get started with Longhorn. So just imagine that you click mouse click, and then you can have a Longhorn and the persistent storage provided in your cluster. Now you don't need to worry about your persistent storage need for that cluster. So of course, if you want to run a production environment, you might need to do some more customization, like configure where your data disk is. But in general, it's going to be much easier to use Longhorn with Rancher. And the second thing is because we have for the Rancher, in fact, we also have building another mechanism to adding the authentication in front of Longhorn. So if you are using Longhorn separately, and you might need to configure your own, like for example, ingress portal to access the Longhorn UI, which is designed to be more of admin UI. But in Rancher, so those issues has been resolved. So because Rancher is always going to have what we call the magic proxy, and the process to proxy your access to the Longhorn and go through the Rancher authentication. So if you only the users have the ability to access the specified project, like the Longhorn inside and the namespace like Longhorn inside, we're going to have ability to access to your storage. That means that if you have multi-tenant environment, the accessibility of the Longhorn will only going to be limited to the like class admin. So that's the one part that Rancher added more value on the Longhorn. And others, of course, the Rancher with the Longhorn, we can still have the worry-free and intuitive GUI dashboard, and you have snapshot backup and recovery with DR volume with defined RTO. And of course, probably the most important thing with Rancher and Longhorn is you can get the Longhorn support from the Rancher Labs and now SUSE. Yeah, so that is the only option available for the Longhorn support at this moment. It's not because that we don't want to support other like environment. It's because we're still like expanding, and there are many like other factors inside. So if you are using Longhorn open source version on other Kubernetes distro, no problem. You can still like raise the issue in the Longhorn GitHub, and we are follow up. So our community engagement, as you might know, is already very active, and we have helped a lot of users with that problems. So if you have any problems, still feel free to raise it. But if you have the Rancher support, and the Rancher support do have SLA defined, and you can get a much better and much faster response. Well, that's going to be a little bit different, right? Okay. So for the Longhorn's feature, as I mentioned, this is what's the currently major feature set. Longhorn itself is enterprise-grade distributed block storage software for Kubernetes, and we support volume sync provisioning and the snapshot and backup restore. So the snapshot, Longhorn snapshot, is always made inside the cluster, Kubernetes cluster, and Longhorn also have a built-in like an incremental backup restore mechanism, which enables user to back up the single volumes to the outside cluster, like in the S3 or NFS server. So, and also Longhorn supports volume expansion and cross-AZ replica scheduling. So cross-AZ replica scheduling is especially useful in the case that you are running Longhorn on top of cloud providers, like for example, EKS or AWS. So as everybody knows that EKS, when they have the manage the Kubernetes cluster, they have the nodes distributed on different AZ, right? So that part, in fact, is very good, but there's one limitation, and in fact, very big problem with that is, as you know, the EBS volume, the storage provider in the EKS, the persistent storage provider, is not really able to migrate across AZ. So in the worst case scenario, if you have one AZ down, there's no way the part you're starting up in another AZ going to have the data, because that's the data which reside in the EBS volume might still be on the first AZ. And also, there's in fact another advantage of AWS, the using Longhorn on top of AWS, is there's a limitation how much EBS volume you can attach on a single node. And also, normally when you request EBS volume at the storage, you are going to request more of a bigger size, like a few hundred, a few terabytes. So if you only need storage like a few 1 gigabytes, 10 gigabytes, those kind of, Longhorn can be there to help you to carve out those huge high performance EBS volumes and make your workload make it the volumes more suitable for your workload. So Longhorn also supports storage tags for node and disk selection and cross cluster DR volumes, which define the RPO and RPO. So this is the one feature we have introduced early on, and it allows you to have a main cluster and the backup cluster, and the backup class can constantly asynchronously replicate the data, replicate the volume from your main cluster through the help of a middleman, which is normally a S3 or NFS server. So if your main cluster goes down, and the backup cluster can be brought up immediately because the data has already been restored there, and you can start running the same workload with that replicated data and to minimize your service downtime. So Longhorn also supports live upgrade and without impacting the running volume. This feature has been there since 0.3, 0.4, and we have made a lot of improvement on that. And now we are basically guarantees that the live upgrade should be almost always available, and except that we did some, if we are going to do some upgrade breaking changes, we are notifying the users ahead of release. But normally we are trying our best to guarantee that will be the really, really very rare cases. And of course, Longhorn comes with very intuitive UI, and also is free and open source to use, and the one-click installation, as I mentioned before. So, but what is new with Longhorn 1.1? So for the 1.1 release, first time we have added the native ReadWriteMany support. It's still marked as experimental because we do, that's one part of this ReadWriteMany support still need to be improved. That is, if the node went down, in the actual cases, if the node went down, the downtime is still a little bit long. So currently the downtime, if you have actually the node went down, it's about 2 minutes, 2 to 3 minutes. So that's one part is what we are still looking to that to improve, and we are potentially going to address this issue in the next minor release. So, but now you can just create ReadWriteMany volume on top of Longhorn, just as how you did it with ReadWrite1's volume. And as long as you specify the PV to be PVC to be ReadWriteMany, and they will automatically request a ReadWriteMany volume from Longhorn, which I will explain later, is backed by the NFS server, in fact. And the next thing is one of the oldest issue in the Longhorn has been addressed, which is ARM64 support. This is I think the issue number of this ARM support is like a single digit. Well, considering that now we have thousands of issues open up codes, of course, in the GitHub. And now we see that the trend of the ARM, and also thanks to our community members' help, and we finally got ARM64 support in the 1.1 release. And now you can run Longhorn on your Raspberry Pi. Of course, need to be 64-bit one. So there are also users asking about ARM 32-bit support. This is not in the plan yet because we do believe that the majority of the community, even at the hobbyist, and might move to the 64 support, like a 64 version of the ARM very soon. So if you we rather like we have to prioritize the issues and features we support. So currently the ARM 32-bit support is not really in the plan yet. We also added the premises support, and now you can use the premises or Grafana or dashboard anywhere, and as long as you connect it to the Longhorn endpoint. We have more detailed documents about this in our website, and help you to set up premises and premises operator, or you can just using like Rancher monitor solution. And then the most thing we are going to automatically set up for you, and to have this the overview of your volumes and the node status for the Longhorn system, as well as how's the volume usage inside the Longhorn system. So the CSI snapshot support is also added for the 1.1 release. So in fact, the CSI snapshot is going to be translated into backup instead of snapshot in Longhorn. So when you have a CSI snapshot, and you need to still, as you do normally with the backup, you need to set up the backup target, and then the CSI snapshot. You need to also, if the distro doesn't include the CSI snapshot by default, you still need to install that. But all of this the steps has been documented on the Longhorn side as well. So now you can use this feature to create a backup and in the command line, rather than like completely depends on either UI or your settings in the storage class. So we have also enhanced the failure recovery mechanism, and now Longhorn supports very fast failure recovery for both stateful workload, stateful set, and deployment. But I just want to mention that soon after we released 1.1, we found out there's one bug in the Kubernetes 1.19 and the 1.20 release that the Kubernetes upstream made a mistake, and by accidentally remove a one key tenant of the helping the failure recovery. So that bug has been fixed in the 1.12, 1.22, and the backport is still in progress for the 1.20 and 1.19. So if you have some issues with failover recovery on the down nodes, that might be the reason. And we're urging upstream Kubernetes to fix it very soon. I think they probably should be done in the next patch releases for the 1.20 and 1.19. So we also have a lot of work getting into the node maintenance. So previously on Longhorn 1.0, we don't support the drain operation, and now the drain operation can be gracefully supported thanks to one community member. So help to find out that using the pod disruption budget is really helpful to control the Kubernetes drain process. And also we have added the features like replica eviction and the pods rebuilding, so you can have more control over how Longhorn works in your system when you perform the node maintenance. Finally, we have added data locality support for the users that with the unstable network. As you know that Longhorn always going to have mostly going to have like more than one replicas to achieve the highly available for your contents and make sure that one node went down, we're not going to affect your system. But there are cases that user have, in fact, very unstable network, like in some edge cases, and those network interruption can in fact interrupt the Longhorn's service to the volume. So the data locality support we're adding here is to try to schedule a replica co-located with your workload. So even when the network disconnected and for a brief period of time, the workload itself still has access to the volume by using the local replica. And when the network comes back, the Longhorn can automatically pick up what is left off previously and start rebuilding other replicas if needed. So that's all for what we had in the Longhorn 1.1. In fact, there's much more content in there and many more features we have added. And you can refer the full context and the full feature set to the Longhorn release note, and as well as our official Longhorn documentation site, which is docs.longhorn.io. So one special thing I want to talk about is how we implement the ReadWriteMany support. So as you can see here, still previously we have two nodes here, and one node say this part one asking for volume A, and this volume A in fact is not ReadWrite1's volume, it's not block device, it's asking for ReadWriteMany. So what Longhorn will do is still like have the replica and the engine connect to it and expose block device, but this time we are going to create another entity called share manager for this volume. The share manager is essentially an NFS server based on this block device provided by the Longhorn. And the share manager, we're going to expose this NFS mount, NFS server to the volume A. And so that's when there's another request coming and still want to share the volume A, but on different node, that request we're going to get response for this share manager. This is also implemented in our CSI. And they know that, okay, so I can use the same volume, and that connection will coming from another node to our NFS server reside in the share manager. So if we have another volume requested, we can have the share manager access. I create the share manager and the volume B as well. So that process is essentially the same for the other volumes as well, if you're choosing to use the ReadWriteMany support. All right, so that's all for my part. I'm going to hand over to William.
All right, thank you, Sheng. Okay, so now we will start with the demo. So, all right, we got this working now. What we see here is a Rancher UI. Hopefully you guys are familiar with this. We've got our sort of common starting point in the Rancher experience. Let's go here to the dashboard. Actually, that's where we normally start. I wish I could ask like the audience, how many of you know the Rancher UI? That's usually what makes this a little easier to do the demo, but of course this is all virtual. So I'll just assume most of you understand how Rancher works. Rancher is a way to manage Kubernetes clusters. So just keep in mind that we're using Rancher to manage a cluster that I've built in advance, but this could be any Kubernetes cluster. So there were some questions about like, can you use Longhorn on OpenShift, or could you use Longhorn on, XYZ other Kubernetes distribution? Yes, of course. Longhorn is a CNCF project that works with any of them, but for the purposes of demoing you some of the features, it's a lot easier to achieve that with Rancher managing that Kubernetes cluster. But again, Rancher can manage any Kubernetes cluster, so this is still very ubiquitous. So the first thing I'm going to do is deploy Longhorn, and to do that, I've created a project which is essentially a namespace isolation within this cluster called storage. And now I'm going to deploy Longhorn. Now, typically, if you think about deploying a storage technology, it's a fairly involved process that you might do over the course of an afternoon with some nice coffee breaks in between, or tea, or whatever you want. Maybe a light snack if you get kind of hungry, like I do in the middle of an intensive IT project. But in this case, you're going to notice it's actually a little underwhelming, almost disappointing if you really enjoy those, deep technical journeys like I do. It's just going to be really easy. All we're going to do is go to the app catalog, type Longhorn, find the app catalog entry for Longhorn, and we're not even going to deal with all these settings because they're really only necessary if we're doing something special. And we're just going to click launch. That's it. And we can kind of end the webinar now, even if we wanted. That's basically everything. No, just kidding. Yeah, I mean, this could be, the webinar could be for another storage technology. The whole webinar could be just on talking about how to do this, and we're already done with that. So that's one thing that's kind of unique about Longhorn. You can see here, if we look at the the deployment view, everything is a container. I think Sheng brought this up. Everything is a container in Longhorn because we're orchestrating this entire storage stack for Kubernetes first. Like, we never designed Longhorn not to rely on Kubernetes. If you need something that's like, doesn't require Kubernetes, there's lots of great storage solutions out there, but we want to be the best in class for the Kubernetes world. And so that's why we designed everything around it. And consequently, we're also leveraging pre-existing software. Like, there's so many things in Longhorn that we didn't have to reinvent or build a duplicate function for, which means less memory, right? Because we're not duplicating more code. So that's less memory consumption, less areas to maintain code for, less potential for bugs, less surprises because we implemented something slightly differently. If you know Kubernetes, how it works, you're going to find a lot of things intuitive. So that's a big distinction or identity of Longhorn, is it's very intuitive if you are familiar with Kubernetes. So we've deployed Longhorn now. So what can we do with it? Well, we can take a look at the Longhorn UI now. And so this is the user interface just for Longhorn to help us understand what's going on in our storage. And you can see here we've got 3 nodes, and across those 3 nodes, all the storage combined gives us 296 gigabytes of storage schedulable. And if I look at the node view here, then I can see everything about the node specifically and what they're doing inside my cluster. I can look at what disks are attached currently. I can even add another disk. So if I mounted another disk on the node itself, I can tell Longhorn to use that storage as well. Again, Longhorn just uses the Linux file system. It doesn't directly manage the disk. It doesn't format it specially or require direct I/O to the disk. It uses the Linux block scheduler and the file system that's on top of that. So, but it does need to know which path essentially on the Linux file system it is allowed to consume. So that's where we might add another disk in that sense. Okay, so that's my node view, which will become more useful as you see when we start adding storage to it. I can see pretty much everything's the same about them now because there's no storage really being used on any of them, just the base minimal storage for starting Longhorn. If I go to the volumes page, I can see the volumes that I might have created. And then backups won't work yet because I haven't set up a backup target. And then here's all the settings for Longhorn. One thing that I love about the way Longhorn's designed is how there's these intuitive explanations of what every setting means. Because I certainly don't like to change settings without knowing what I'm changing. Some people like to live on the edge, I guess, like that, and flip a setting on and see what happens. But most of the time, that's not my favorite. I like to be well informed before configuring a software like Longhorn. So that's helpful. Now let's try to go ahead and deploy something so we can see what happens when we use volumes, and then we can see what the UI will provide for us there. So here's my default workspace, my default namespace. I'm just moving out of the Longhorn 1. So we have a clean view of what we're going to do next here. And I'm going to deploy something from the app catalog again, which for those of you who don't know, app catalog is simply a Helm browser. These are all Helm charts and Helm repos, and this is just a way to browse them. Okay, and so I'm going to look for the ever famous reference application WordPress. This just seems to be the thing everyone likes to use to demonstrate a piece of technology these days. So we're going to do the same. And for this one here, I'm going to enable persistent volumes here. I'm going to give it a password. And I'm going to tell it to use the Longhorn storage class, specifically in this case. And my database will also need a volume. And use the Longhorn storage class. Okay, and that's it. So now I'm going to launch it. And so what's going to happen here is Kubernetes is going to, of course, decide which nodes to schedule these pods on, but it's also going to make a CSI request to Longhorn asking Longhorn to provision a couple volumes. And then Longhorn's going to get some time to work on that. And once they're ready, Longhorn will attach those to the container. So if we look here, we should see now the 2 volumes that have been requested. And they're actually already starting to come online here. So we can see the volume name, the PVC name. We can see its status, if it's bound or unbound. We can see the namespace it's in. We can also see what pod or workload it's attached to, which is kind of convenient. And if we take a look at the volume itself here, we can understand a lot more about what's going on. We can see things like the actual size on disk. Remember, Longhorn volumes are thinly provisioned, so the actual size on disk is going to be, potentially less than the allocated size to the volume. We can see settings like data locality and access mode and many other things here. I can also see on my replica. So default Longhorn settings defines 3 replicas for every volume. And so that's what we have here. We can always change that per volume. We can make it more or less and change the default as well. But in this case here, I've got a replica on demo node 1. These are nodes that I've created already, demo node 2 and demo node 3. So I've got 3 replicas evenly distributed across 3 nodes. So I've got really good HA right now. And I can also do things here like take a snapshot, and I can even create a backup. In fact, let's go ahead and let's look at what it looks like to create a backup here. So let me configure the backup store, of course. So if I go to settings here, and I go down to the backup section, backup target here. And I've already got a secret in this case with my credentials set up there. And now I should be able to see backups. Okay, it's possible that I cleaned that secret up. So let me go ahead and just recreate it. Just make sure I got that in there. Okay. So I'm just going to quickly recreate it here. And Adrian, if you hear any questions that you think I should cover, feel free to interject those.
Well, we actually have a bunch of questions. I've been flagging them and answering a bunch. So I don't know to whom these should be directed. So you can answer them or Sheng can answer them. And we will just start. Ian wants to know, the architecture diagram suggests 2 nodes. I'm gonna turn my camera back on so I can be cool. Everybody loves my shirt. Sorry, everybody who's been asking me for this shirt, it's really old and vintage. It still says Mesos on it somewhere, so they don't exist anymore. So Ian wants to know, the architecture diagram suggests 2 nodes. Is this the minimum, or do you need 3 nodes to ensure that there's no risk of a split brain if one of the nodes should fail?
Yeah, I can answer that question. So there's no concept of the split brain in Longhorn because we always treated any failed replica as, well, something went wrong. So Longhorn can function with 1, 2, 3, up to 10 replicas, but I rarely think anybody will configure like 10 replicas. Our recommendation is on 3 replicas, but it's not because that we need a quorum somewhere. It's just because that we want a little bit extra of the guarantee of your data safety and for the highly available data.
That's cool. Eusebio asks if Longhorn is suitable for large block storage or more for small bits of persistent storage.
So Longhorn, in fact, has a limitation on how big the volume is. That is limited by the size of your disk. So as you can see previously from the diagram, the Longhorn's volume size Longhorn's replica always on the one disk. So that means that that replica cannot be bigger than that disk. So if you have a very, very big disk, then that won't be a problem. But if you have smaller disks, yeah, so the limitation will be on that, and you might want to tweak your applications, or if you want to have really storage pool across the whole cluster, then other solutions like Ceph will be a solution. But of course, that's going to be much more complex and much harder to operate.
Right. There's a question that's come up, and I have this question as well. So I'll throw this out there, and we'll see. I run a DigitalOcean cluster with DigitalOcean's Kubernetes service, and I was using Longhorn, and this was a while back. This was even before 1.0. And DigitalOcean did some emergency nonsense where they destroyed and recreated all of the nodes. They basically did a rolling update of all of the nodes. And I had external volumes attached to them that I was using for Longhorn. And when they did the destroy and recreate, all of the workloads restarted, but they didn't reattach the volumes. And I've seen guidance from hosted Kubernetes providers that say, don't attach block storage to your nodes. Instead, attach block storage to the workloads themselves from within Kubernetes. So my takeaway from that is that Longhorn isn't the best solution, not just Longhorn, but Longhorn, Portworx, OpenEBS, like all of these solutions that depend on a node having external block storage attached to it aren't good in a hosted Kubernetes environment for the very reasons that I described. I asked William about this offline, and he said that he knows that there are people who are using it on EKS, and it will work. So is there any solution to the problem that I described? Is it no longer a problem, or discuss? There's a bunch of questions.
So there are multiple things here. So first, for the hosted Kubernetes, there indeed this problem that they think everything on the node is disposable, so they can just freely like remove it and like restart it, and they don't really know there's a state in there. So we saw some users. In fact, one of the features we have introduced in the 1.1 is some users, they do have a script, and they are going to automatically reattach the external disk back to the node that even like because normally the node name will likely, at least in his case, node name will remain the same, but you just need to, attach the volume back, then the Longhorn will still work, right? So that is one thing. Another thing is we also, if the hosted Kubernetes distro, they follow the standard procedure of like upgrade a node, they should do drain, right? They should do cordon the node and drain the node, and when drain is complete, they uncordon the node. But the thing is, so the one thing we have introduced in the 1.1 release is now Longhorn has the ability to control the drain process by utilizing something called pod disruption budget. So Longhorn will not leave that node or allow the drain to be continued if there's only one, the last replica, like the last replica of any healthy volume is on that node. So that will give like Longhorn enough time to do the rebuilding and migrate data over. But I have to say, yeah, this is basically the fail-safe solution, and we aware of this action for the hosted Kubernetes like providers, and we're still looking into more details to see that either say if that's what's this reason say you're not attaching the node like the storage back, which I found is pretty weird, and or is there any other better ways to deal with this situation? But for now, those are the two solutions we have at the moment.
Okay, cool. William, more questions, or are you ready to continue?
Yeah, I can continue if that's all right with you.
Okay, yeah, take it away, and we'll come back to questions later.
Okay, so let's take a look at this backup settings that we just established. So when we set up the backup store, then now we can see what backups exist in our backup store, and there's some from previous Longhorn installations that we've worked with here. And as well, now we can also back up existing volumes to that backup store. So let's go back to our PV here. And actually, I think it was maybe this one we were working on. So let's take a snapshot. And now we can create a backup. And in a second here, we should see that backup is now being created and uploading to S3, and we'll see it listed here as well. There you go, created a few seconds ago. It's still in flight, so we're not going to see it completed yet. Yeah, it's still in flight. But that's how easy the backup process is for a volume. So again, we've got a volume here that is being used by a pod, but then from the Longhorn view, we can very quickly find out how many replicas it's got. We can manage its disaster recovery and durability. Another thing too that's really powerful is recurring backup and snapshot schedule, which we can schedule through the UI as well, so that we've got a point-in-time recovery now at any given interval that we select for our data. It's really powerful. And just to be clear too, the snapshot is copy on write. So it's a thin provisioned, in a sense, copy on write snapshot. So there's very little cost to accumulating these in your cluster. So you can retain the ability to go back to a point in time in your data history for very little cost and very little impact on I/O, which is convenient. But then if you want to have a disaster recovery option, if you were to lose the whole cluster, you want backup, which is actually shipping that entire data set off to your backup store, which is either NFS or S3. Okay, so that's how backup works, that's how volumes work, and that's what we can see from the UI here. And we've talked about some of the settings that we can customize very easily. So that's cool. So let's take a look at now what happens in WordPress here when we use it a little more in some different ways. So for instance here, right now this pod is running on demo 2, and it's been running for 13 minutes. One of the things we want to make sure is that if we lose this pod here, we expect the pod to get rescheduled and that volume to be attached on even another node. So let's go ahead and try to simulate what happens if we lose node 2 and we have to redeploy, reschedule that pod. We want to see that our data is able to recover. So to do that though, I want to first look at the WordPress app itself. So we have some way to test that the data is in fact retained. So let's put some data into it. So we set this up in the beginning here with a login. And let's create a post. Hello, CNCF world. Just to sort of make sure we all know that there's, the data that we put in here is going to stay. All right, so this was created today, February 17th, by a prolific writer named User, and it says, hello, CNCF world. So what we want to make sure is that we don't lose this blog post essentially if we lose the container that's serving it. Right now there's one container serving it. And so if we lose that container, what will happen? So what I'm going to do here first is this is on demo 2. I'm going to coordinate this node here so that no new workloads will get scheduled on it. And I'm just going to delete the pod, simulate a pretty aggressive failure. So this is our database pod. That's a problem, right? If we delete our database pod. And in fact, let's see, the WordPress app is going to be a little upset. Yeah, I think it would have a problem establishing a database connection. So we've lost the container, and we've lost ostensibly the node because we've made that node inactive or cordoned, so it's not allowed to get new workloads. If this was a non-Longhorn Kubernetes world, what would happen? Well, we would have to be using something like local path or host path, and that data would be stuck on the node, meaning if we lost that node, we don't have a way to recover our application because that data is all on the node. And the cool thing about Longhorn is because of its replication pattern, which is very tunable and very adjustable, like Sheng said, you can have as many as 10 or more replicas if you wanted for really high durability. We default to 3. But because of that replication pattern, we have the data now distributed beyond the fault domain of a single node. So a single node is no longer a dependency. We don't depend on any single node. This goes back to the whole mantra of cattle versus pets, right? We don't want to have pet servers. Instead, we want to be cattle farmers with our servers so that if we lose one, we can just replace it with another server. So what's going on now? Well, now it should be creating a new pod because it's lost the existing one. And it looks like it has chosen node 3 to put it on, which again is not where we started. Let's just take a look here. We can read the logs. So it's no, that's from the
I think it's getting there already. The container was started.
Yeah. So you can see here is this is where it attached the volume a minute ago, and then it had to sort of create the container and then let the. I think there's an init pod in this container, or this pod has an init container which has to initialize the database, so that has to run first. And now it's running. So now we've got our WordPress MariaDB container running. And so now what would we expect to have happen? Well, if we try to use this application now, or if we went on the container and tried to look at the file system, we'd expect to see our old files there, right? Because that's what persistence means, is that the persistence means the files will persist beyond the container lifecycle. So we can test that by reloading the app. And there you go. So there is the post that we made on the old container. This is definitely not what's out of the box with WordPress. This was definitely not in the image. This is definitely this is new data that we've introduced into the system that it did retain. So that's really good. That's a good outcome, and that's what we want to see. Now, obviously, too, if we wanted to get fancy, we would perhaps have some scale here. We would have multiple pods running, and we'd have a way for the workload to coordinate between those various pods. And if we lost a single pod / node, this recovery could even be in the background, right? Because the other 2 pods or 3 pods would continue serving traffic while we rebuilt this pod in the background and moved its data around. That would be sort of a more advanced use case, which you can imagine. But with MariaDB here, in this case, we don't have replication and set up and the things to make this work on the application layer. But Longhorn has the technology available for that should your application support it. Okay, so I want to show you another use case, though, switching gears. That's kind of it for WordPress for now, which is this new use case is ReadWriteMany. ReadWriteMany. So both of the volumes we created today, the 2 volumes we created here, are read write once block devices. So they're only used by the single container at a single time. What we're going to do next is create a volume that's going to be shared among multiple containers. And to do that, I'm going to deploy some YAML code, which is going to have all of the components that I'm going to need to do this, because I'm going to need a few more moving pieces. And I'll take a look at it with you real quick. The important thing here is we have a persistent volume claim, and we specify this access mode here, read write many. So this is going to tell Longhorn that we need a different type of volume. And I think Sheng went into the architecture of what we do under the covers. There's actually a lot of mechanics going on whenever we ask for read write many, but that all happens seamlessly to the user. All we have to do is just tell it we want that. So that gives us our volume. And then for the deployment, to use that volume, we're going to create a 3 replica deployment. So 3 pods running Nginx, all sharing the same volume. It's going to use this exact same volume here. This is not a template. This is not a PVC template. This is an explicit singleton reference to a singleton of a PV in this case. So this is basically what we're going to deploy right now. In this case, Nginx is going to serve a file that is going to be written to by another container that's going to append the date to it every 10 seconds. And this will just prove to us that no matter which time we access the Nginx pod, and it's going to be any pod because there'll be load balance, we're going to see the same file across all 3 pods. It'll make sense when you see it. It'll make more sense when you see it. Okay, so we're going to call this our RWX test.yaml. I'm going to put this code in here. So just to show I've got this set of resources here in Kubernetes that I'm going to deploy. There's a service here as well, and that's going to be just for routing between the 3 Nginx pods. We need something to be the distribution point for incoming traffic. So kubectl apply-f test. Okay, so created those 3 things for us. If we go to our workload view here, we can see now that being created. There's the 3 pods. And do we have a volume? Yes, we do. We now have a volume that's been created as well called RWX test. And this is a read-write-many volume. To also make this a little easier to look at for all of us today, I'm going to add an ingress here. And I'm going to call this, and we're going to use an auto-generated domain. And so I'm basically just going to point all traffic to this auto-generated domain to the service that we just created, read-write test and select port 80. Okay, so a couple things have to get kind of cooked in the oven here or prepared by the Kubernetes brain. Give it some time. So again, when this starts up, there's going to be 1 container writing to this file, constantly writing new data every 10 seconds, and then there's going to be 3 containers reading from that file to serve it as HTTP traffic. And the reason they can read that file is because they're all pointing to the same volume that shares that file. So you can see the data path now flowing between all 3 containers to 1 volume. You'd think Nginx wouldn't take so long to start. It's a pretty simple container, but, or no, so this is Ubuntu. Let's have, oh yeah, the writing container is Ubuntu, and then Nginx is the serving container. I guess we could take some questions, Adrian. This might take a minute or 2.
Okay, there are lots of questions. There are more than a minute or 2 of questions. We've got a bunch of really good ones. Let me turn my camera back on. All right, let's see where to start. We have some super storage nerds in here who are asking about performance and IOPS. And let me see if I can find one of those questions. Let's see. How do you measure performance or I/O latency, etc., with Longhorn? And is there any export to like Grafana? This is from Gerardo, and specifically he's wondering about the SLA, KPI, SLO, and a bunch of other TLAs.
Yeah, so currently for the 1.0 release, we have a performance report which is available at blog longhorn.io/blogs. So we currently measure the performance on bandwidth side. Longhorn is doing pretty well, and the write bandwidth is the same as native disk, even for like 3 replicas, and the read bandwidth is in fact bigger because like we round robin read from all 3 replicas. So I think we got like 2.5 read bandwidth. But on IOPS is the part that Longhorn now still need to improve. I think there are some third-party benchmark show the Longhorn is on performance and is on par with the SAF. But we are also planning some changes on the front-end part. Currently, as you might know, Longhorn is using ASCII to post the block device, and in the future we might want to switch to the. In fact, we do have plans to switch to the NVMe over either TCP or even like more other solutions to speed up the process of having the data shipped from the user to the Longhorn engine to shorten that path. So that part is the one key point we are focusing on for the feature releases, since now the stability seems good, and also the feature set, which is already have a lot of user suggestions and take a lot of things in count. So we are pretty much also satisfied with that. So our next focus will be on the performance improvement. And given the simple architecture of the Longhorn, we don't really think there's going to be much difficult for us to get like really top-notch performance.
Wonderful answer. Thank you. Next, we have a question from Ian, who says, if performance is key with the storage, can the volumes be thick provisioned rather than defaulting to thin?
In fact, currently we don't see a really big difference from like thick provisioned versus thin provisioned. Yeah, we can do like more tests on that, but if you like looking at like SSDs, it's all considered as random access. There, the latency is almost the same for the sequential or even for sequential or for the random access. So at least to my understanding, I don't see a very big difference between the thick and thin provision.
Okay. Jens wants to know if it's possible to have two storage classes like SSD and SATA drives.
Yes, so you can have two storage classes, and you can also using say those two storage classes are going to have like different storage tags, and you can define those tags on your node or on your disk, and then whatever being scheduled by those two storage classes is going to just place the replica on the corresponding node and disk.
Cool. Dominic has a question that implies, well, it sounds like he might have had this conversation with you or somebody in the past. So he asks, did you lessen the recovery time in Longhorn volumes spread across multiple virtual machines in multiple vCenters? Do you know what he's referring to?
Sorry, not sure.
Okay.
Yeah, I think
well, Dominic, if you want to.
Yeah, so
Dominic has confused us.
Really, yeah, we don't really treat vCenter differently for the Kubernetes view. That's just Kubernetes cluster, right? Is any like specific things on the vCenter like preventing Longhorn to like? No, sorry, I don't know what's the specific about vCenter in this case.
Okay, no problem. So Dominic, if you're experiencing something specific, go ahead and open an issue and on GitHub, and we can certainly start a conversation about it. Next up, we're getting a lot of questions about backups, about using external backup solutions, and some people are curious. Is there an integration with Commvault? Is it possible to back up any endpoint? And if I were to collect all of these questions into one, it would be outside of the snapshot and backup functionality within Longhorn, is it also possible to use a backup solution to back up the data? Do we support the volume snapshots and the other things that backup providers like Valero and Kasten and Commvault are using to perform backups of Kubernetes?
Yeah, so currently we have one standard backup like pathway there, which is CSI snapshotter, and I think that already there are users in the GitHub like mentioned that he has successfully run the Longhorn with Kasten and just with the CSI snapshotter mechanism and make sure that backup everything that just works well. So that's as long as the backup solution there and the support the CSI snapshotter, it should be fine.
Okay, great. William, how you doing? You want us to switch back to you now?
Yeah, sure. I think we've got something ready to show. So.
Okay, back to you, sir.
Thank you. All right, so let's see if this will show us what we think it will show us. So we've got our two containers running here in this pod, and again, there's 3 of these pods running. And so all 3 of these pods and the containers inside of them are now sharing the same volume. One thing to point out too is I kind of got this wrong when I first described this. is the writing container, the container that's writing to the file constantly. There's actually one in every pod. So there's going to be 3 writers all writing this to the same file, kind of appending, and then there's going to be 3 readers all able to read from the file, and we'll get a different Nginx reader depending on which each time we make the request to the load balancer. So let's take a look at the load balancer, see if that's ready. Okay, it says it's ready. Well, that's going to be embarrassing. It's going to work on Chrome and not Safari. Something's wrong with my DNS cache, apparently. So let's switch screens. The great browser wars continues, and apparently Chrome has won at this juncture. All right, so in my Chrome browser, you guys can see that now, right? Here we have that load balancer that is now directing traffic to all 3 of those Nginx. Okay, so as you can see here, it's not the prettiest website, but there's a file being served here that all the writers are writing to at the same time. So if I kind of refresh this a few times, you're going to see this move at the bottom. So keep an eye out for that. So there we go. See, as I'm refreshing it, how it's moving. That's because with all 3 writers, each 10 seconds apart, they're kind of interleaving or collating against each other, and so you're getting quite a lot of activity. But every single time, too, we're also getting a different Nginx serving this as well. So you've really got the 3 write paths and 3 read paths in your data plane, in your data path here. They're both being exercised equally, and you can see that works pretty well. This is the magic of the distributed file system, right? So yeah, that's what we'd expect to have happen, and that's the benefit of ReadWriteMany. So let me go back to Safari now, where we have the rest of our demo. Let's just see if this works now. Maybe now, yeah, there it goes. So it got jealous that Chrome was working, and now it decides to work too. Should have known.
Except you're not sharing anymore.
It says I'm sharing.
There we go. It's probably just my lag from being in South America. I see you now. Sorry.
I had to hit it again to get it to turn on. I don't know why. But now it is working in Safari too. There you go. Okay, cool. So we've got a blog that we've created using persistent volumes. We've got a very magical time page that we've also created using ReadWriteMany volumes. Let's look at one other thing in Longhorn that we just released, which is our monitoring support. So to set this up here, I'll show you first how we set this up. So this new monitoring extensions for Longhorn allow us to get some insights into the volumes and to the Longhorn engine itself in our monitoring system. So if you're using Rancher, you can simply add this to your deployment of Longhorn within Rancher, and then in the Prometheus monitoring component within Rancher, this data will show up. So first you need to enable Prometheus in the apps marketplace within Rancher, and that's a little beyond the demo today. That's beyond the scope of what we'll do today. But there's plenty of documentation about enabling monitoring in Rancher. Assuming you've done that, then you need to add the Longhorn metrics exporter to your system so that that data starts flowing into the Prometheus within Rancher. So to do that, we're going to deploy that YAML that I just showed you there. I'm just going to go and launch a Kubernetes shell again. I'm going to call it mon.yaml, put this in here, and then kubectl apply f.yaml. Okay, we created it. All right, and now if we go to I get rid of that tab, I might have, yeah. So now if we go to our cluster explorer here, and we click on monitoring, and we look at Grafana, this is Grafana in general here. Then we should have a dashboard in here now. called Longhorn example 1.1. All right, there we go. And you can see here that we've got some interesting data. We got our number of volumes, number of healthy volumes, number of attached volumes. We've got the volume capacity at a per volume level here, and how much storage is used. And we've got all these other cool things about the nodes themselves, so we can see as nodes start to fill up with disk. And of course, keep in mind, this is all through Prometheus and Grafana, which has an alerting framework built in. So any of these metrics we can create thresholds on. Like, for instance, if any of my nodes go beyond 85% utilization, maybe alert me that I might want to continue or consider adding more storage. This lets me know the CPU and memory usage on the nodes, which is useful. I can see specifically the components of Longhorn, what they're consuming in CPU and memory. Here's the manager. Manager is a component that is shared across the entire cluster. And it's orchestrating kind of everything at a global level. And then also too, there's also some storage metrics that are exported through the CSI interface now. So if we look at this standard Kubernetes dashboard here, we'll get to see at a per volume level some data as well. So if I look at the last 15 minutes here. So here's our WordPress namespace and specifically the claim for, or the volume for, let's look at the MariaDB one, that's more interesting. There's MariaDB. And you can see there, well, let's look at it for 15 minutes because there's a bit of a gap. Yeah, we can see how much free space is on the volume and how much is currently used. Only 179 megabytes out of about 8 gigs. And so this is nice too for monitoring a per volume level. And that's now built into the metrics view within Rancher. Okay, so that's about it for the demo for today. So we can go back to questions, and thank you so much for your attention and time, and I hope this was informative. And I hope you guys are excited as we are about Longhorn 1.1. So Adrian, I think I'll hand it back over to you at this point.
Oh, keep your screen sharing, because if you have to show anything with the questions, then we'll go from that. Okay, we have questions. I'm just gonna go through the, oh my gosh, there's more questions rolling in. All right, starting from the top. Is there anything special to upgrading Longhorn, or is it just like upgrading any other application via Helm?
Yeah, so in fact, Longhorn has two-step upgrade. First one, you need to upgrade the Longhorn Manager, which is you can do one click from the Rancher UI and then boom, upgrade it. But after that, because Longhorn also have microservice engines, like I mentioned before, so you for the 1.1, you need to go up there and in the volume and select each volume you want to upgrade, and normally it's going to be a bunch of time and then upgrade it. And for the 1.1 release, we are introducing an experimental feature to help you upgrade your engine automatically. And by the way, I mentioned before that Longhorn engine, in fact, can be upgraded without like impacting data paths. Your workload can still read write data from it. Well, in the time, just let engine upgrade. It's like a switched engine when you playing is on the fly. So that's the one part. We don't have 100% guarantee what is like say it's always going to be supported, but we are trying our best to first. It's definitely going to be supported for the patch releases. And we are trying best to get it all supported on the minor release as well. So for now, the 0.8 to 1.0, 1.0 to 1.1 all supported live migration, live upgrade.
Cool. David has a question about over provisioning. He says, we've been working with Longhorn, and one thing that typically comes is right-sizing your disks to work with the replica set and overcommits at 200%. So if you have a 20 terabyte raw, when you add in the replicas and then the overcommits and of course the reserve space, you could really end up with nodes going unscheduled because of the settings, even if the total amount of actual used capacity is maybe 1% of the actual physical storage. And while there's not a question there, I think he's saying, how can we prevent that?
Yeah, in fact, that's an interesting thing because we set the default value to like 200%, which means you can like on a 1 terabyte disk, you can like provision 2 terabytes of data. And we set to previously in the early releases, you might remember like Longhorn is like 500%, which means you can have 5 times the data. We shrink that down. The reason is their user complains that they're over provisioning and they're using up too much space and the cost disk pressure on the use case because they think they're still have the space, so they continue to like provision. So I have to say that it's going to be depends on case by case and what's your usage pattern of how you use volumes and what's the real like space that's going to be occupied by the volumes, right? So Longhorn is trying to guess what's the best thing out there, but if you like say you generally over like provisioning a lot, you generally like just want to be a more conservative, then yeah, that's the parameter you probably want to treat.
Okay. Scott has a question where he says, Rook/Ceph has the advantage of being able to be mounted as ReadWriteMany, which can help for in-place zero downtime upgrades of stateful applications, whereas ReadWrite1's volumes make zero downtime upgrades a challenge for those same stateful applications. He's asking, how can this be handled in Longhorn with the ReadWriteMany functionality being considered experimental? What's your guidance?
Yeah, so when you say that Rook/Ceph, I think you probably mean CephFS instead of Ceph itself, because Ceph by itself.
Yeah, he said CephFS. That's my bad. I read that wrong. CephFS.
Okay. Yeah, so because Ceph itself is also the ReadWrite1's storage like Longhorn. So yes, if you have a distributed file system, like yeah, sure, you can do a rolling upgrade if you are using like a deployment. But in the Longhorn cases, and we're still working on the more stable and highly available version of the ReadWriteMany. So we currently have a few pathways to get there, but no guarantee yet. But yeah, we're working on that. But on the other hand, that if your application is like the more scale out instead of scale up applications, and then the storage and using the ReadWrite1 storage makes more sense because you have the best performance from ReadWrite1, and also your application knows how to distribute the data and not going to cause outage during its own like upgrade process.
Oh, that's a great answer. That's really smart. Okay, so there's a lot that can be done in the application design component outside of just relying on the storage. That makes sense. Rudy asks if everything that we've seen today can be done via kubectl, kubectl, or if it requires that it be done through the kube.
That's a great question. That's currently, I would say if you do it very carefully, yes. But currently, the only one part which is relatively safe to change is on the settings. Because on the volumes, we use a lot of CRDs there, but we haven't really expose them to the end user because there are some like validation hook stuff we haven't like put in place. So currently, Longhorn UI is communicated to the Longhorn managers through exposed API, which is built on basically on more like RESTful API instead of kubectl like CRD type. So in the 1.2 release, we are planning to bring the kubectl experience into Longhorn and make sure that you can operate the volumes and the replica, not replicas, the nodes and the backups are using the kubectl instead of relying on the UI. So currently, you also have another way to talk with Longhorn API is through the Longhorn Python client. We also have guidelines in there. And if you want to have more programmable approach, and you can check our document for how to using the Longhorn Python client to communicate with Longhorn Manager Server to achieve whatever you have seen in this demo today.
Nice. That's cool. I didn't even know we had the Python library. That's fantastic. Klaus asks, well, Klaus says, let's assume that we have 3 replica sets in Longhorn and 10 nodes in the cluster. How are new pods handled so that they're placed on nodes that already have a replica?
Sorry, I didn't get the question.
Let's say that we have 3 replicas in Longhorn and 10 nodes on the cluster. How are new pods handled so that they're placed on nodes that already have a replica? Is that,
Yeah.
does that happen at all?
Okay, so if you have 3 replicas, and okay, so I'm not sure this is your question, but my understanding is that's how does Longhorn like guarantees that the replica has been for the spread like across the cluster. So for example, if one node has, for example, for the volume A, you have a replica 1, 2, 3, sorry. And then if the replica 1 is scheduled on the node 1, and then the node 1 will be no-go for the remaining replicas, and Longhorn will have a schedule mechanism to decide to put the replica in nodes other than node 1, which can be node 2 to like node 10, right? So that is what we call hard anti-infinity building with Longhorn. So, but if you think about, say, if you have another volume, and then this anti-infinity rule will not be in place because we don't have explicitly saying that, yeah, you have to schedule, say, for example, the replica 1, 2, 3 of node 1 on node 1, 2, 3, and then you cannot use 1, 2, 3 for the volumes number 2 because they're 2 entities. So we don't take that into the consideration for the scheduling.
Okay. Klaus, if that was not the answer to the question, please ask the question again and we'll come back to it. Next, we are getting a few people who are asking about a roadmap for what's coming. You've talked a little bit about what's coming in 1.2, and they're asking if we have anything that we plan to share in this session for upcoming features.
Yes, in fact, William?
Yeah, we have a slide for that. I was just going to suggest.
Yeah.
Let me see if I can switch back to. I think we've kind of mastered the screen sharing at this point, I hope. Have we?
Ooh, that was very nicely done.
Getting better, step by step. All right, so what's on the road ahead? Everyone always likes to think about where things are heading with exciting technology like Longhorn. We're the same. So we're actually, kind of somewhere in this part of the road here, right? Although it'd be on the right side of the road, except if we're not in the US, we'd be on the other side maybe. Never mind that part. But we said we're on this road right after the 1.1 milestone. And as you know, we'll just recap, we've just added ReadWriteMany support, ARM64 support, extended metrics and monitoring, CSI snapshotter support, and also the advanced failure recovery automation. And so what's coming next? Well, now we've got things like performance enhanced front end. And Sheng alluded to this a little bit. There's definitely some options we are still considering as to how we would implement this. If it's something like NVMe and over what encapsulation or SPDK or all sorts of different technology at our disposal. So we're really trying to think carefully about the best option. A Longhorn CLI, which there was a question about, could you do all these things through kubectl? That's a great question. CLI would also sort of be assisting in that same vein for people who are more CLI focused. Application backup and restore. This one I'm really excited about because now we're really completing the story of disaster recovery and full regional failover for Kubernetes applications, because it's not just the storage now that we'll be capturing, we'll also be capturing the Kubernetes metadata that associates with that storage to orchestrate the application. And so you can think of now a holistic top-down backup and recovery strategy that encompasses all facets of your application. Storage, the manifests in Kubernetes, the container definitions, settings, config maps, all that stuff that we need. So that's really exciting in 1.2. And an enhanced API. Gosh, what does that mean, Sheng? Enhanced API?
So in fact, this one is more related to the kube control, using kube control to modify the CLDs to do the API operation. So that's our goal, and for this release as well.
Very good, very good. Because I thought the API was pretty stellar already, so I was curious what we would enhance, but you answered it there. Future release 1.3, way at the end of the road, somewhere over the rainbow. We're going to think about QoS, so quality of service constraints and guarantees for volumes in a very busy or very multifaceted clustered environment where there's lots of different competing IO interests. We might want to be able to change priorities. Backup encryption, so encryption at rest, volume encryption, also encryption at rest, if you will. And sharding, that's a big frontier right there. Something that I know other SDN technologies have, SDS technologies have, and something that we would also consider for 1.3. Could definitely add some benefits in terms of total capacity of storage in a heterogeneous cluster, for sure. So that's exciting as well. Yeah, I think that's kind of the summary. 1.3 is probably that's probably 2022, right, Sheng? So that this is quite a lot of road to think about already.
Yeah.
Awesome. Thank you for the
Excellent.
question, though.
Thank you.
I would have forgotten about the slide if they didn't ask.
They're here to keep us honest. All right, we still have a bunch of questions. Remember, everybody, this is being recorded, so if you need to drop off, you'll get a link to where you can come back and watch these later. True to the Rancher ethos, we will stay here until we get all of the questions answered, or until everybody leaves, whichever comes first. So let's see if we can come up with some technical questions for William. Peter says, can we talk a little bit about security? So could a malicious pod encrypt a Longhorn volume somewhere else? That sounds like a ransomware kind of question.
Malicious pod encrypt. So like take a volume, take over a volume, encrypt it with its own key that only it has.
Yeah, it sounds like if somebody's pod got compromised, could it then encrypt Longhorn volumes elsewhere in the cluster to prevent those pods from accessing them?
If one pod only going to have access to whatever has available to that pod, which might be a Longhorn volume. So, well, I would say that is basically guaranteed by the Kubernetes, that if the Kubernetes has a hardened policy on, say, this pod cannot access that pod or that part resources, which is defined by the RBAC rules and stuff, then I'm not going to worry that going to happen. Yeah, but of course, if the ransom software have the access to your root disk, not root disk, to your nodes, and as a root user, well, it will going to have access to anything. So.
Interesting. So, okay. I will.
Yeah.
We could probably go down a rabbit hole of talking about RBAC and network policies and various other things, but that's totally off topic for this. Does Longhorn support volume resizing?
Yes. Volume expansion is. Volume expansion means that we can only support like resize it to a bigger size, and currently Longhorn only support this in the offline mode as well. Yeah, so we do have to fix that for the analog mode as well.
Okay, is that something that's easy to demonstrate or more involved than what we have time for? Because we still have about 15 questions to go through.
I'm not sure that we have prepared to demonstrate that, but that should be very simple. So you have Longhorn volume, and you can just edit the size for the PVC, and then the once, of course, if you pull this down, and because PVC will still be there, right? PVC definition, and you update the size of the PVC, and then the PV and also Longhorn volume should be automatically resized automatically. We do have articles on how to do this in our documentation as well. Yeah, volume expansion on the volume and nodes.
Okay. Thank you for that question, Dan. Gerardo has a question about the time that it takes to do a rollout or an upgrade of Longhorn. In his example, he says we have a cluster with 50 nodes. Let's just imagine that there's 50 nodes using Longhorn and we update to the latest image version. How long would you estimate that it would take? And by comparison, he's saying that with Portworx, it's about 6 minutes per node to do that update.
What? Okay, sorry.
That seems like a really long time, right?
Yeah, that's a really long time. Yeah, so for the Longhorn part, on the manager part, I will imagine everything should be up in. I'm not going to say a few. Yeah, I think I'm going to say a few seconds. I think very likely we haven't tested that, so just my gut feeling. But there's nothing blocking on the management pod upgrade level. I would say should be up to like 5 minutes top.
Okay.
For all the nodes to have the manager part. We do have a bug saying that manager were going to be like upgrade one by one, but now that one should be fixed. So I think that should be much faster to do that now. But for the engine part, for the volume engine part, yes, each of the volume we're going to take like 5 to 10 seconds to upgrade, but you can upgrade multiple at the same time. So, well, I don't imagine it's going to like take 6 minutes per node to upgrade. Yeah, should be faster. Should be much faster.
Okay, so manager up in a few minutes, and then volumes a few seconds each.
Each one are going to take like a few seconds to upgrade.
Yep. Okay. And I understand this is our best guess. Environmental conditions do apply.
You have okay. Now give me a moment. Let me see if I can pull that out. The installation.
All right. While you're looking for that, I'll see if I can find a question for William. So William, Larry says, great demo, and he's wondering where he can find more info on Prometheus and Grafana. And we also had somebody ask if those dashboard charts are they installed by default, or are they available somewhere? Is there some extra step that they have to go through to install those?
Yes, great questions. Yes, it's essentially all in our documentation. The dashboards, some of those are built into the Rancher monitoring out of the box as the default dashboards. And then there was the first one I showed you, which was the Longhorn 1.1 example. That's a specific dashboard you do have to add for that example one. That's all in our documentation. Sheng, do you know where that is?
Yeah, so you can take a look at our doc, and when you scroll down the left side, there's something called monitoring, and you can see that on the integrated Rancher metrics into integrated Longhorn with Rancher, and you can see there's something called Longhorn example dashboard.
Yeah, so if we go here, this is where I added the service monitor component. That's where I got the code for that. Here we go. Here's the example one that I just showed you. So you can basically use this ID in Grafana to import it, or they give you some instructions right here of how to do that import. And then the other dashboards are built into the Rancher monitoring deployment when you enable that in Rancher 2.5.
Great. Dominic came back with an update to his question, but I'm going to flag that one for later, and let's just run through some of the ones from the top. Is there any limit to read and write speed, or is it like
no? Currently, there's no limit, no restriction on that level. So that is still going to be considered like the QoS part.
Okay. Let's see. Volumes backups using this tool. Okay, we'll come back to that one. Do we have any published benchmarks comparing Longhorn to other solutions that are out there?
We have a benchmark for Longhorn itself, but we normally don't compare us on the performance. Yeah, for others. So there are a few I think third-party resources, and there are some user and doing benchmark across Longhorn and other competitors, and you can take a look at that. So frankly speaking, I know currently the Portworx is probably still the best performance out there, and the Longhorn is the performance level is currently on par with Ceph. And the current solution of the OpenEBS like Jiva and C Store is pretty slow, but they do have a new engine come out called the Maya Store. So, but it's not GA yet. So that's what I know at this moment.
Okay, that's a great answer. Yeah, people like Portworx comes up a lot, but remember, Portworx is commercial only. It's expensive, and you pay for it, and that gives them tremendous amount of resources to invest back into the product. Everything that you're seeing here today with Longhorn is free and open source, and we have resources allocated to it and doing development on it, but our objectives are to make a lightweight, fast, free, open source solution. And we're really focused on building value into the product. And we don't spend a lot of time, comparing it to other things. We just want to make it the best with the features that the community is asking for. Next up, oh my God, we got more questions rolling in. Let's see here. Oh, here's an easy question for you, William. Ricardo's asking, how did you get to the Longhorn dashboard? Because he missed it. Can you show that real quick?
Sure, yeah. So from within the Rancher UI here, then actually let's go back to cluster manager here. So there's a couple ways. In the way I showed you earlier from the cluster manager view, in the project that Longhorn's been deployed to under the apps tab, which is loading.
Loading.
And then this link here is /index is linking to the UI. And then from our
Cool.
view UI as well, or the sort of new UI cluster explorer, you can also find it top left here under Longhorn.
Great, thank you.
Mm-hmm.
Rudy says, in each picture, and I think this is referring back to the slides, in each picture you show the pod is local to the Longhorn volume, and he's wondering if this is always the case, or can the volume exist on node 4 and 2, but the pod on node 1? I don't know if this is a question about the pod that's using the volume, like the thing that has the volume mounted.
Yeah, in fact, I got asked about that a lot. So the Longhorn's connection to the replicas is through the network. If it's a local, of course, it's going to be loopback device. If it's the remote, it's going to go through the network over Kubernetes, over the networking. So there's no hard requirement to have the replica on the same node. But if you do want that, there's I have mentioned before that data locality feature can help you with that. If you want to have the replica co-located in case that your network went down.
Okay, cool, good question. Mike wants to know, what is our recommendation for getting data into a Longhorn volume? Like we could, mount it directly as a path, or is there a cleaner way to populate a new volume?
Yeah, so normally I think we do have one example in our ReadWriteMany documents, just say how to get to the existing Longhorn, how to get the data into existing Longhorn volume. We currently suggest that you just bound your old volume and the new volume as the two paths of the pod, and then you're using the pod to copy that over. I think we do have some example YAML files for that too.
Okay, and that's in the documentation?
Yeah, let me see if I can find relatively.
Okay, while you're looking for that, I'll try and find a question for William. Dominic's back with an update. We'll get to that in a sec.
Oh, yes, in fact, William, can you, I just send you something internally, 1 second. Yes.
Sure. Okay.
Scroll down to the bottom. There's a script you can use to migrate anything to Longhorn, and doesn't need to be like ReadWriteMany. It's just a script that have the two PVC mount to it, and then they just copy the data over. Yeah, this case is especially for the previously external provisioner we provide for the 1.0.x release.
All right, looks like Rudy had to leave, so I just made a note to follow up with him. Okay, there's a question here for Sheng that's a little bit involved. It's from Dominic, and it says, unfortunately, I can't find the GitHub issue where we discuss the volume growth problem, but in that issue, I had a volume of 2 GB for Prometheus, but Longhorn specified 20 gigabytes as the actual size, and 20 gigabytes were also occupied on the nodes. Prometheus itself only used 1.5. Longhorn's snapshots accumulated 18.5 gigabytes.
Oh,
And that's not a problem if you have a 100 gigabyte volume and a 1 terabyte of storage, but it could be brutal. Has that improved in Longhorn 1.1?
yeah. In fact, that's the mechanism is still there, but what you can do is because now it's not about the nominal size of the volume. For example, if you say I allocate a Longhorn volume which is 20 gigabytes, and then if the Prometheus repeatedly writing to the disk and on different locations, because Longhorn is handling blocking level, it doesn't know what the file system looks like. So if the Prometheus keep writing everywhere into this, so this disk can up to like 20 gigabytes, which is the nominal size when you create a disk. But if this disk is allowing like 2 gigabytes, and then because of the Longhorn snapshot, and you can like delete that snapshot. And also some of snapshot might be automatically generated when you have in like a node failure or replica failure. And those snapshots previously, we just like classify them as system snapshot, and they will be deleted when next time anyone like going to there to delete the snapshot. But now in the 1.1 release, if you have a rebuild coming up and rebuild complete, we're going to start automatically delete the system snapshot to keep the space consumption to the minimum for your volumes. Yeah, so if that's because of snapshots, just feel free to, if you don't need those snapshots, just feel free to delete them. Also, you can also set recurring snapshot or recurring backup, which I really recommend to have to use the Longhorn backup feature to ensure the safety of your data.
Okay. So one of the disadvantages of answering questions during the meetup is I don't actually get to pay attention to what the meetup is discussing because I'm like madly answering questions over here. William, in your demo, did you show replication with the DR site? Was that part of the demo?
That wasn't in this demo, no. We actually have some other webinars where we've done that.
Yep.
Maybe we could link.
Did you discuss it? Did you explain how it works? The question is, how does replication work between a DR site? Maybe if you could just take 15 or 20 seconds and explain that process.
Yeah, so okay. I can answer that. So what is happening on the DR side, the DR side and the master side is going to point to the same, for example, AWS S3. And the master side, when they are going to schedule like recurring backup, like shipping the data to the DR side you can say every hour, every half an hour. And that is what your RPO is, recovery point object. And when you have the node go down, so what's happening now after the backup was shipped up to the S3 or NFS server remotely, like to the external of the Kubernetes cluster, the DR side, we are going to constantly pull in the new data from the S3 on NFS server, and then they are going to update whatever is inside that their own volume. But at this time, the volumes on DR side are not usable, and we call this it's not activated, it's inactivated, it's constantly getting new data. So that is also getting away in the delta form. So you don't need to worry about waste your bandwidth or like waste your precious time when trying to do the recovery. So in the end, if the master side went down, on the DR side, we are going to automatically like pull. Of course, when you activate the DR volume on the DR side, the DR volume, we are going to pull the latest data again, also incrementally, and to make sure that they get the latest data, whatever has been shipped to your backup store, and then create the volume out of it. And one side note is the PVC name and the pod, all this information already recorded in the backup metadata. So on the DR side, you can just one click create the PVC and in the same namespace as before and start using the volume and with the same workload as before. Yeah, so there's one demo. In fact, multiple demos I did before. And for this scenario, we can find out the links for my previous demos and yeah, probably post it somewhere.
Cool, thank you. Hang on, I gotta write somebody else's name down here to reach out. afterwards. Okay. Going through, man, still a lot of questions here. We already answered the question about, do we have a plan to limit IOPS per volume? I think that was here a couple of times.
Yeah, so just one very short supplement. So the IOPS limit is doable, like doing the QoS stuff, but if you want to like guarantee a disk IOPS, that's a little bit hard because that's not a function that has been like provided in many systems.
Oh, looks like we lost William. He probably sent me a message that said he had to go to another meeting. It's just you and me now here. Cool. And I think I'm the only one sharing. Oh no, I see you. You're up there as well. All right. Okay. So we'll get back to that guy. That is unrelated. Oh, there was a question. You might have actually answered it offline. Somebody asked if Longhorn runs on Windows. Did you answer that person directly?
Oh yeah, I think I answered it. This no, currently Longhorn doesn't run on Windows because yeah, everything is on the Linux, especially on the data plan that we're assuming that you're using x64 or XFS or some file system support like Spotify and DirectIO.
Okay. That makes sense. Vasilis says that read write. Blah, okay, this is now it's the part of the meetup where I start to lose the ability to talk. Vasilis says, how about volume expansion for ReadWriteMany volumes? Does it work for those types of volumes or no?
Yeah, there's a bug. I think there's a bug. Yeah, we'll fix that in the
There's a bug,
we have a bug number and we'll fix that. I think we're already very close to fix that in the 1.1 release, and that will be shipped on that. Yeah,
okay.
Sadly, we found that after.
That's okay. You know, at least we're fixing them. Can you mix storage backends on a cluster that is comprised of ARM and x64 nodes? It's a question from Zachary.
I do not think there will be a problem unless like your ARM's cluster is like super low powered compared to the x86. But yeah, in general, yeah, I don't see at least from the architecture perspective, I don't see a major issue there.
Okay, but it's not something we've specifically tested, but we don't see any reason why it wouldn't work.
Yeah.
Okay. I love answers like that. Will it work? Maybe. There was another question here from David. David's asking about stale NFS file handles if the NFS connection to the PVR pod goes away. The dreaded stale NFS file handle. How do you handle that?
Oh, I think in the most cases, if the NFS server went away, that means the node of the NFS server is down, and then we are going to start, at least for this release, we're going to start the recovery process, which is involving killing the workload pod to make them reconnect. If the pod is still holding the file handle, I think it will be gone when it's killed, and then just reconnect. Yeah, in the future, when we start dealing with the HA, like more robust HA cases, yeah, that might be an issue. And also,
I mean, this is just the way that NFS works.
Yeah,
if NFS goes away and doesn't come back fast enough, then you're going to get stale NFS file handle, and the only way I've ever seen to recover from that is to reboot the client. In the case of a pod, that's a lot easier than rebooting entire servers. But I used to build HA NFS clusters with DRBD and CoroSync, and usually it worked. But if failover took too long, it's a disaster. That's just the way NFS is. It doesn't like having
we know that some parameters can be tweaked, like I remember some parameters like hard mode or soft mode, but yeah, we're still like investigating on that part. But now we technically approach.
Dan says, Dan is working with Longhorn 1.0. It says if we have 2 worker nodes, hang on a second, let me read this first. Okay. Interesting. If we have 2 worker nodes and we install Longhorn, then an error occurs on replicated volumes across the nodes because it has a default setting of 3 volume replicas, but there's only 2 worker nodes. Is there any way to change that default, or do they just always have to remember to set 2 replicas?
You can, so short-term solution, you can set the source, you can enable the source and divinity. And for the 2 nodes, and the long, at least slightly longer answer is if you upgrade to the 1.1, we have added a new function called allow volume creation with degraded capability, which means that at least if as long as you have like 1 node available for the replica scheduling, then yeah, we can create it. But yeah, you can also like using soft and divinity. But if you really make sure you only have 2 nodes there, my suggestion is, yeah, you probably should change the default replica setting on your like storage class. And yeah, it's not recommended to change storage class in the 1.0 release. We have introduced a new way to change storage class, like default storage class in the 1.1 release. Like you can use a config map to do that. That is synchronized because there are some upgrade issues with Helm. You can always create extra storage class using the Longhorn driver and specify different parameters. That always works.
Okay, cool. There you go, Dan. Great answers. Multiple options available to you. Mohammed is asking if it's possible to use dedicated network interfaces for Longhorn traffic, like how if you build an iSCSI data communications path, you can have it.
Yeah, not yet. So currently Longhorn traffic goes through the over networking of the Kubernetes, yeah, but that has been brought up.
Okay. Using active volume and another cluster for cutover DR scenarios. So Scott's asking about the DR failover. Again, not sure when. We might have already answered that. Otherwise, it is covered in the documentation. We're getting now to the part of the meetup where we gotta kind of hurry up through the questions here. Oh, and it might not have even been Scott. Scott apologizes because apparently there's 3 different people logged in on the same GoToMeeting session as the same user in the Starbucks. Patrick, is the way it goes having backup regularly. Is there a way to automatically clear snapshots after some period of time?
The short answer is yes, but so the snapshot can be generated from the replica rebuild, or you like manually create snapshot, or you're setting a snapshot like recurrent job or backup recurrent job. So in general, normally what we're concerned about is the system generated snapshot, which will be for the 1.1 release will be automatically cleaned up once the rebuild was completed. But if you have like recurrent snapshot or recurrent backup setup with certain retain number, every time when a snapshot was deleted or the like system snapshot, we're going to clean up automatically. Of course, if you manually create a snapshot, you need to manually delete it.
Okay, and we have full support for any S3 compatible backend, right? Minio, Ceph, any type of object store.
Yeah. Okay. The only one exception there is, don't know why, due to some reason, the Google Cloud S3 list functions seems very slow compared to any other like vendors out there. But other than that, as no issues, we solved now.
Okay. Mike has a follow-up question about migrating data from an existing external provisioner and wonders if there's any strategy or if we have any means to view the data within a volume without accessing it through the pod that has it mounted.
Yeah, so if it's a ReadWriteMany's volume, we can just directly attach the volume to one of the Kubernetes node, and then it will be exposed as block device on the node, and then you can just mount it on the node and read from there.
There you go. Peter says, thank you to all of us. That was a very interesting session. We will forward that to William, who had to go. We already answered that question. And Motorola Intel storage. And Larry has an NFS story for us. I'll read that later. And jumping back up to the top, Longhorn AKS, map was deployed for Helm chart, create some volumes, and Helm system volume. Oh, interesting. Gerardo says, if my app was deployed via Helm chart and it creates some volumes, and then we upgrade the app, so it creates some volumes with Longhorn, and we upgrade the app via Helm, does it maintain consistency with the volumes that were created?
I suppose so.
And it's not really a Longhorn question, it's more of a Helm question, right? You would want that
They should
functionality
use
to exist.
volume, right? They should use the same one.
Should use the same volume. It should just, yeah, it should update the deployments, which recognize that they're using a volume, and it should just work. Okay. But again, it's not something we've tested because it's not a Longhorn issue. Last question is from Rudy, who's not here, but we'll watch the replay later, asking if Longhorn has a toolbox like Ceph. Oh my gosh, a whole bunch of questions just rolled in. Does Longhorn have a toolbox like Ceph to manage or show status? I think that's probably covered with the Grafana stats that we saw. I'm not familiar with the Ceph toolbox.
Yeah, so that's why it's the one part that we show the metrics, yes. But another part is we are also like planning to have a Longhorn CLI, which is exactly going to allow you to like operate Longhorn objects on the CLI instead of like even go through the CRD. So that is the one thing we have in plan for the 1.2 release.
Do we have an estimate of when 1.2 is going to drop?
I would say hopefully this summer, but as you know, anything related to data paths is going to take a longer time, and now we want to really improve the performance and do a big change there. So yes, so that's going to be like our estimate, but that's not guaranteed yet.
Okay. That's it for questions. Everybody's saying thank you, thank you. This was awesome, thank you. I'm just going to share really quick for those of you, the 113 of you who are still here. Gonna make myself a presenter, and I'll just remind you of where you can go for information. Let me jump back to there and show. Yes. So remember, Rancher users Slack is your home for the community, for any questions that you have. We have a Longhorn channel there. I'm assuming we do, right?
Longhorn-storage. I don't know who take the Longhorn name.
Oh, somebody created Longhorn and we can't. That's funny. So yeah, so Longhorn-storage is the channel to go to if you have any Longhorn questions. That's staffed by users as well as engineers. But any questions that you have about Rancher, K3S, RKE, RKE2, whatever it is, Kubernetes, my shirt, join us in the Rancher user Slack and bring your questions there. My name is Adrian Goins. I am the Director of Community and Evangelism. I want to thank you so much for joining us today. And Sheng, do you want to say a few words of farewell?
Yeah, so thank you everyone for joining. And I have to say that from the starting, the Longhorn community project, we have a lot of feedback, a lot of like advice and feature requests and bug report from community really helps Longhorn to be growing in today's to the degree that Longhorn is today. And we have over, I think 20,000 or 21,000 nodes work right now and running Longhorn. And I would say see from the starting, this is really impressive, but it's really contributed to all of you guys that get engaged and get advice and to us, right? Thank you everyone, and still follow up and getting any issues, come to the Longhorn Slack channel or have a go to the Longhorn/Longhorn to file issues or requests, and yeah, that's all I want to say. Thanks.
Awesome. Thank you all. Have a great rest of your week. Stay safe. We'll see you next time.
See you.